There is two benefits of nickel where it is used in aerospace engineering and as a component of nickel-cadmium battery.
Nickel is highly valued in aerospace engineering for its ability to endure extremely high temperature without losing stability or strength. This is primarily due to its face-center cubic crystal structure, which does not change even at temperature above 1000 degrees. There are four uses of nickel in aerospace engineering, which include its property of corrosion and oxidation resistant, wear resistant, and also act as components such as turbine blade and used in production of nickel-based superalloy. First of all, nickel is used in the production of nickel-based superalloy. Nickel-based superalloy are designed to offer outstanding strength and durability, which is essential for the aerospace sector. One key method of strengthening the solid solution strengthening, where elements like chromium and molybdenum are added to the nickel. These elements integrate into the nickel's crystal lattice, creating distortion that impeded the movement of dislocation that defects in the crystal structure that allow for plastic deformation. Next, nickel's resistance to corrosion and oxidation is another significant advantage in aerospace applications where material often face harsh environmental conditions. Nickel forms a stable oxide layer, which is nickel oxide on its surface, which acts as a protective shell against further oxidation. In nickel-based superalloys, the inclusion of chromium enhances this protective effect by forming a chromium oxide layer, which offers additional resistance against high temperature oxidation and corrosion in aggressive environment. Besides, the ability to resist wear is essential for materials used in aerospace, where components are frequently subjected to mechanical abrasion and erosions. Nickel alloys achieve excellent wear resistance through the formation of hard carbides within the matrix. These elements, such as carbon, chromium, and molybdenum in the alloy react to form carbides, including chromium carbides and molybdenum carbides. These carbides are hard particles that resist deformation and abrasion, which significantly enhancing the wear resistance of the alloy.
Other than that, nickel is also used as one of the components in batteries. The commonly used nickel batteries in daily life include nickel-cadmium battery, which is a rechargeable battery. Nickel oxyhydroxide is an active material as a positive electrode in nickel-cadmium batteries, whereas the negative electrode is composed of metallic cadmium, and these electrodes are separated by a nylon divider. The electrolyte used in this battery is aqueous potassium hydroxide. These nickel-cadmium batteries are produced in two designs. One of them is sealed nickel-cadmium batteries and another is banded nickel-cadmium batteries. The sealed nickel-cadmium batteries are commonly used in commercial electronic products such as rechargeable batteries used in remote controls and lamps. Compared to sealed nickel-cadmium batteries, the vented nickel-cadmium batteries seem to be safer since the oxygen and hydrogen gases will release through a low-pressure release valve when overcharging or rapid discharging occurs. This property also makes vented nickel-cadmium batteries to be more economical, lighter, and robust than the sealed one.
Despite its advantageous properties, nickel also poses several health risks. Inhalation of nickel dust or fumes, which can occur in manufacturing environments, can cause respiratory problems such as chronic bronchitis and asthma. According to the research done by DAS, long-term exposure to nickel compounds has been linked to an increased risk of cancers, particularly in lung and nasal cancer. Nickel is also a common allergen that can cause contact dermatitis, which is an inflammatory skin reaction characterized by rashes and itching.
The environmental impact of nickel mining and refining is very significant and multi-phased. According to Genchi et al., the extraction process can release pollutants like sulfur dioxide, contributing to air pollution and acid rain. Acid mine drainage caused by the oxidation of sulfide minerals exposed during mining leads to the formation of sulfuric acid, which in turn causes the contamination of water bodies and harming aquatic ecosystems. The long-term environmental consequences include degradation of water quality, soil contamination, and harm to plant and also animal life in affected areas. Additionally, improper disposal of nickel-containing waste can lead to the soil and also water pollution. Nickel ions can be toxic to plants and animals, leading to bioaccumulation of long-term ecological damage, underscoring the need for responsible waste management.
In short, we can see that nickel is an element which can benefit the society. Despite from its fundamentals, nickel also gives harmful effects to the community. Therefore, the uses of nickel should be handled carefully to avoid the contamination and pollution to the environment.